Hello, my name is Emily Kennell, and today I'd like to tell you about my capstone project, Arm Prosthetic for Independent Farmers. But before I do this, I'd like to tell you a little bit about why I got interested in doing prosthetics for my capstone project. When I really got interested first in prosthetics was when I read this manga, Fullmetal Alchemist. In this manga, one of the main characters, Edward Elric, has a prosthetic leg and arm. But the character who really inspires me from this is his prosthetist, Winry. She's just so enthusiastic about her job and really good at it that it made me want to do that too, because I could see myself being like her. So when my parents got me this Lego Mindstorms robot kit, I created a Lego robot arm. And as you can see, it had an elbow, and it could pick things up, and it had a rotational axis, and it could drop things on command. And in 2016, I created this paper arm armor for myself that actually gave myself a really free range of movement. I've also always loved to draw, especially organic creatures. Whether they're real or imaginary, and I love to look at the way that they moved and study that, and also understanding the structure and the forms, things that I really loved. So you can see that I always had an interest in this sort of thing, and so this brings me to my capstone premise. What if I could work on a project that encompasses my interests, using technology to imitate organic structure and movement, pushing the limits and exploring what's possible, designing valuable and meaningful solutions, and solving design engineering problems. So now let's talk about the process. I used the double diamond design process for this, and I also used the design thinking methods from the Harvard Business School. Now, if you're not familiar with the double diamond design process, it starts out with a general problem. Then it moves through the discover and define phases to narrow down the problem into a specific problem. And then it goes through the develop and deliver phases to get to a final solution. But my design process wasn't just this neat division, because I actually spent most of my time, 8 weeks in fact, in the discover phase doing research, and then even more of this in the define phase, doing more research and narrowing stuff down. So the double diamond would look a bit more like this for me. I also used a Gantt chart to keep track of all of my progress and keep myself on track with what I needed to do when, so that I could get it all done on time. So now let's talk first about the discover phase. In this phase, I did a lot of research, and I'd like to take you through that. To help keep myself on track in my research, I developed this general problem statement. How might we design a device that removes users' disability, restores their self-respect, and allows them to keep their vocation? And I created this mind map of everything I knew about prosthetics in order to help me better understand everything involved in them. My research actually revealed a lot of problems to solve with prosthetics, an overwhelming number of them, in fact. Initially, I decided to focus in on the leg because a lot of the problems seem to revolve around that, but as you'll still see, my research actually led me away from this eventually. I also, during this research, decided to go with a future goal of 2035 is the year for when my project would be viable by. This later goal would give me the freedom to dream without having current constraints and costs of things getting in the way. Most of my research was centered around the user, so I spent a lot of time watching videos of people with prosthetics and in order to understand them, and also interviewing people. For instance, I interviewed a kinesiologist and a prosthetist. And I took my insights and my findings from these, and I mapped them on empathy maps. And an empathy map is where you note down what a person says and what they think, what you think that they are thinking, and what they do, and what they seem to be feeling. And then you pull insights out of this so that you can better analyze and understand what you've seen. And I made a whole bunch of these, and then compiled them on a empathy map highlights map so that I could better collect my thoughts about all of it. During all of this, I had a serendipitous moment when I was interviewing Dr. Norman down at Cedarville. He's an engineering professor, and his daughter actually has a prosthetic leg. But one thing that he said to me was, the bases are actually really covered in legs already, and there's more need for innovation in arms, especially in blue-collar workers, which is what I was looking at the time. He suggested then that I focus in on an arm for farmers, since farming is a very intensive blue-collar job that would have a lot of need in the area. And one reason why I thought that this was an extra good idea for me is because my dad is actually a farmer, and this is a picture of me helping him plant sweet corn. So of course I had to interview my dad. And this is one thing that my dad said. My guess is it would be the most demanding application out there to design prosthetics for farmers, maybe even more so than for sports, because for sports they can be more customized, whereas farmers do a lot of different tasks that they have to deal with throughout the day. Some main things that he pointed out that farmers have to do is steering and shifting equipment, lifting heavy objects, holding and turning 2 wrenches at once, which would require 2 hands, holding on while standing on a step, which requires your prosthetic to be able to hold you and pull you up and support your weight, pulling on a rope, like for instance leading an animal or lifting things, and just about any other job you can think of. Another insight I found from my interview with my dad was that farmers are very tough, stubborn, and resourceful, and they will do their jobs even if they have disabilities. So all of this brought me to my specific problem statement. How might we design a device for arm amputee independent crop farmers that allows them to return to work with no deficits and maintain their self-sufficiency? These are also some statistics that I pulled out. There are 2 million US farms, 89% of which are small family farms. And as I mentioned earlier, these independent crop farmers that I'm designing for are people who have small family farms as opposed to large group farms where a lot of people would be working at once. Farm accidents are twice as likely to end in amputations than any other industry. 11% of all farm accidents involve amputations, and 1 in 10 farmers actually will suffer an amputation on the job. So you can see that there's a real need for this project. So then I was ready to move into the define phase. In this phase, with my user selected, I focused on understanding them and narrowing down the problem into something specific that I could solve for. So first I created a stakeholder map in order to understand the general network that a farmer lives within. And then I created a mind map in order to understand all the different jobs that a farmer has to deal with throughout the day. And I decided to focus in on these 2 main areas, fieldwork and equipment maintenance, because these are 2 of the areas that the farmers will have to deal with the most, and also some of the areas with the most need. And I also zoomed in on each of these in order to understand what all was involved better with each of them. And this is what a lot of farmers use currently, which has been called the farmer's hook. It is rather simplistic in the things that it can actually do, but a lot of farmers prefer this over more complicated modern prosthetics because a lot of fancier modern prosthetics just aren't able to hold up to a lot of the tasks that farmers have to do throughout the day. Then I created journey maps in order to look at each of the areas of farming that I had selected in depth, looking at what it might be like to do farming with a hook prosthetic. This one is for driving a combine. 2 pain points that I pulled out of this one was convenient and precise control of machinery can be difficult, and climbing ladders and trusting the prosthetic to support and steady yourself can be an issue, because if your prosthetic is not attached very securely, it can be highly risky to use it to pull yourself up. And for maintaining farm equipment, I pulled out these pain points: lifting heavy objects without breaking the prosthetic, using 2 wrenches to loosen and tighten bolts, hooking up wiring, and working with chemicals and electricity, because chemicals and electricity could damage prosthetic, and farmers have to deal with these a lot. And then I took all of the things that I had found and I compiled them into a user persona. The name of my persona is Persistent but Impaired, because my farmer and farmers in general will continue to try to do their jobs even if it is more difficult for them. A quote that my user might say is, "The job has to get done somehow. Obviously, it would be best to have my real arm back, but I can still work without it. It is pretty frustrating for some tasks not having another hand because I waste a lot of time, but I can't always be asking for help." With my user nailed down, I was ready to move on to the development phase. And in this phase, I started off with an ideation workshop with some of my peers, which you can see right here. We were ideating around these design principles, which I had decided were the important things for my device to be able to do. It needed to be precise, durable, powerful, trustworthy, minimize risks for the user, easy to maintenance, and comfortable. And then I took the best ideas that we came up with, and I charted them on a competitive set in order to compare their strengths and weaknesses. And these are the ideas that I decided to move forward with from this. The first of these is unified with the body and detachable. Now, it should be detachable because this minimizes the risks of it getting caught in something and, like, for instance, farm machinery and having it pull them in or something like that, which is often a common way that farmers would lose their arm in the first place. So having them be able to have a quick release on that is a good idea. And I decided that it should be unified with the body because that makes it more trustworthy, precise, and comfortable. The way that it's unified with the body is osseointegration surgery, which is where it is drilled and then attached directly into the bone. And this allows the prosthetic to not be able to come off when they're trying to support their weight or pull themselves up or lift heavy objects and things like that. The prosthetic won't accidentally just fall off on them or something. It also allows it to be more precise because the alignment isn't variable and it's securely attached to them. And it also makes the prosthetic more comfortable because it removes the need for a socket, which is a big source of discomfort in users today. Sockets are what a lot of, like most prosthetics use today. And things like rubbing on the inside of the socket and sweating and things like that are common issues with them that can cause things like tissue breakdown and irritation. The second idea that I decided to go forward with was powered with exchangeable batteries. And the upside of this is that exchangeable batteries actually allow for longer lasting power because they can switch out their battery for a new one while the other one is charging, and they can keep going throughout the day this way. Because it would be really bad if their arm ran out of power and they were no longer able to use it halfway through the day. And farmers are actually really used to this method already from power tools and things like that they use. The third idea that I decided to go forward with from this was nerve control. And this is where it picks up signals from the nerves that are sent to control the arm. And this is a lot more natural method of movement than something like picking up muscle movements and things like that. For this, I decided that I wanted to use a very new technology where sensors are actually just set against the outside of the stump around it that can actually pick up the nerve signals without being implanted into the body, which is what people would have had to do before. This is a very exciting new technological advancement in the area of prosthetics, and I can see prosthetics going very far with it in the future. The fourth idea that I decided to go forward with, we called the arm quiver, and this is different attachments for different tasks. Now, the idea of different attachments for different tasks is that each attachment can be more specialized for the task, which makes it do a better job. It also allows each attachment to be more simplistic in its design, and it allows for the possibility of users themselves to customize their own attachments to put on their arm for whatever job they would want to do. Which brings me to the fourth idea that I decided to go forward with, made with standard or accessible parts. This allows them to maintenance it themselves and also allows for the do-it-yourself solutions like customized attachments. So I tried to use standard or accessible parts wherever I could. And this brings me to my concept statement. An osseointegrated detachable battery-powered prosthetic arm device that has different attachments for different jobs, is open source for do-it-yourself attachments, and is controlled through analog or neurological methods. And this responds directly to the problem statement, which was how might we design a device for arm amputee independent farmers that allows them to return to work with no deficits and maintain their self-sufficiency. Once I had my concept nailed down, I then moved into a design heuristics chart in order to explore all of the considerations involved with the various rules of thumb that one has to take into account. The rules of thumb that I considered were anticipating needs that the user might have for this, recognizing constraints, creating responsive feedback for the user, matching their mental models of how they would expect it to work, minimizing the complexity of it so that it's more simple for them to understand, and preventing possible user errors. And I took the ideas from this chart and did a whole lot of ideation on it. And this is the idea that I decided to move forward with. It has an elastic sleeve with implanted sensors in it so that it can sense the nerve signals that they send to their arm. It has a strong weight-bearing elbow, an exchangeable battery, and a battery gauge and warning light. It also has multiple attachments that can go on it, and I looked at several different options, but I decided to go forward with the combine driving attachment because I had limited time for this project and I had to choose just one of them. And for the design aesthetic, I decided to take inspiration from tractors and from power tools because this is the sort of aesthetic that you see on the farm a lot and what would fit in with what farmers already have. Then I was ready to move into the delivery phase. In this phase, I started out with prototyping. And in order to prototype, first I had to have something to test my design on. So I created a mock-up of a combine joystick because I needed to test out my combine driving attachment. And the combine joystick is the thing that does most of the main controls on a combine. So I created a wearable prototype for myself out of tinfoil so that I could test the way that the actual ergonomics felt for myself. I found that one finger was enough on its own to have a strong grip, but I decided to go forward with two just for extra security. And by having just two fingers, it makes the whole design a lot simpler and lowers costs and maintenance issues than if you had a whole set of fingers where everything would have to be smaller and there would be more of everything. Then I traced my hand in order to make sure that the scale was right for a real human hand for my prototype, and created this template in order to work off of. Then I created a foam prototype of my combine driving attachment. And if you're struggling to see how this is a hand, I drew a human hand over the top of it so that you can see how it compares. I tested it on the joystick mock-up, and a lot of the testing that I wound up doing on it was on the thumb because of how complex the movements on it had to be in order to be able to press all of the little buttons on the joystick. And I kept ideating and exchanging parts on it until I found the right movement for it. Then I moved into CAD development, and for CAD development I did even more ideating, along with modeling, in order to come up with the best way that the components were configured and put together, and the way that it would all work. And this is the design that I finally came up with. It is styled in a John Deere color scheme, but I'd imagine that farmers could get it in any number of different colors that they would like. Now let's break it down. It consists of the arm and the combine driving attachment. And I also designed the layout of the internals, which you can see here in my CAD model. Let's talk about the arm first. It has these lights on it. It has a warning light, which can flash to let the user know that something is going wrong. And it also has a battery gauge, which is very important for knowing how much power is left. And on the bottom, there's an exchangeable battery, which they can switch out throughout the day. For the elbow, I used a worm gear to create a very strong joint that can lift a lot of weight without being forced backward. And there's also a rotational axis on it so that they can turn their arm around for more complex movements. Moving on to the combine driving attachment. First, let's look at the connection point between the attachment and the arm, which is very important for safety. The connection point is right here. I created a very secure and convenient locking mechanism for this attachment point, where they can press buttons on either side of the wrist and pull the attachment off of one hand, because they're not going to have two hands to do it with. You can see one of the buttons on the attachment here, marked in yellow, and the other one is on the other side. For the movement for the wrist, I used a linear actuator, and all of the motors in this prosthetic are actually using electricity. For the finger movement, I decided to use chains, which allow the entire finger to curl with the use of just one motor. And this was inspired by a do-it-yourself solution that I found a fellow, you can see on the right there, made for himself. For the thumb, I decided to use a more high-tech solution. It's similar to what you see in BB-8 in Star Wars. And BB-8 actually is a real working prop that they used in Star Wars, which uses magnets to move itself. So I decided to take inspiration from that because the thumb required such complex movements around the base of it. I also put a small motor in the knuckle farther down the thumb so that it can move the end of its finger. So you can see that it can move in all directions with the ball joint and also move the fingertips separately so that it can press all of the buttons on the joystick. So how did I address the problem statement? If you recall, the problem statement was, how might we design a device for arm amputee independent crop farmers that allows them to return to work with no deficits and maintain their self-sufficiency? Well, I created an arm that is reliable for supporting weight with a strong internal structure and allows complex movements. I created an attachment for driving combines that allows normal operation of the combine controls. And I allowed for different attachments which can be switched out quickly and easily for different tasks. And that is my capstone project. Thank you for joining me on my journey of creating a prosthetic for independent farmers.